How about 2026?
Welcome, listeners, to another My Mind Mashups deep dive, where we unravel mysteries, spark curiosity, and make sense of complex ideas together.
It's great to be back, and today we're tackling a subject that sits right on that really uncomfortable razor's edge between, high-level physics and just existential dread.
Yeah, it really does. And before we get into the data, and we have a lot of it, I want to start with a specific feeling. You know those moments where reality feels just slightly off? Maybe it's a really distinct sensation of deja vu, but stronger than usual. Or you're looking at a tree in the wind, and for just a split second, the movement looks repetitive, almost like a looped GIF.
It's a disorienting sensation, yeah. It feels less like nature and more like, I don't know, a rendering error.
That's the feeling, like the world around you just stuttered, like it was buffering.
Right.
Today, we aren't just dismissing that as a brain fart. We're taking that feeling and running with it all the way to the top of modern academia. We're talking about simulation theory.
And I know for some people listening, this just sounds like pure sci-fi. It sounds like we watched The Matrix one too many times back in 1999.
It does. But the mission for this deep dive is to steelman the case. We aren't here to convince you that you are an NPC in some cosmic video game.
Yeah.
But we are going to explore why this idea is scientifically plausible enough that, Nobel laureates, tech billionaires, and serious philosophers take it dead seriously. We're looking at arguments from probability, quantum mechanics, and AI that suggest our universe might just be an artificial construct.
That's the key distinction, I think. We aren't arguing that we are definitely in a simulation.
Yeah.
We're just exploring why the evidence suggests that such a scenario is. Well, it's consistent with logic and the laws of physics as we know them.
Exactly. Don't forget to like, share, and subscribe if you enjoy content that makes you think. Okay, so let's unpack this. Where do we even start? I guess with the logical foundation, because this didn't start on some conspiracy forum.
No, not at all. It started in the philosophy department. It did. The modern sort of rigorous version of this comes from Nick Bostrom at Oxford University back in 2003. He proposed what's called the simulation argument. And this isn't just a hunch, it's a formal probability argument.
Based on computing power and, how civilizations grow.
Exactly.
Okay, so this is the disjunctive trilemma, which I have to say sounds like a painful medical condition, but it's really just a three-way logic gate.
That's a good way to put it. Bostrom argues that one of three very specific scenarios must be true. There's no fourth option.
Okay, so let's break those down. What's option one?
Option one is the great filter scenario. This suggests that pretty much all technological civilizations go extinct before they reach what he calls a post-human stage.
Post-human, so like tech gods.
Basically, yeah. They destroy themselves with nuclear war, climate collapse, or maybe runaway AI before they get the processing power to run universe-level simulations.
Okay, so option one is that we and every other civilization out there, we all blow ourselves up before we get the cool toys. That's pretty bleak.
Very bleak.
But let's say we survive. We become those tech gods. What's option two?
Option two is what you could call the apathy scenario. So civilizations make it. They have this massive computing power. But they have zero interest in running ancestor simulations.
Why not?
Well, maybe they're just bored by it. Or maybe they have really strict ethical laws against simulating conscious beings because of all the suffering involved.
So they have the console, but they just refuse to play the game.
Right. Which leads us to the third and final option.
Okay.
Option three. They make it, they have the power, and they do run simulations. And if they run even one, they're probably going to run millions, maybe billions, to test different historical scenarios.
And this is where the math kind of traps us, right? Because if option three is the reality, then there are billions of these simulated universes running on their computers.
Billions of simulated Earths.
And only one base reality, Earth. So statistically, if you are a conscious being living a life like ours, the odds are billions to one that you are in one of the simulations.
Not in the base reality, it's just a pure numbers game. If simulations are possible and they're popular, then base reality becomes the huge statistical outlier. You'd have to be incredibly astronomically lucky to be one of the real ones.
That is heavy. But I know there's been some pushback on those raw stats. There's David Kipping, an astronomer at Columbia. He took a look at this using Bayesian analysis.
He did, yeah. Kipping brought some necessary skepticism to the table. He looked at Bostrom's three options and realized that, from our perspective, option one, where we die,
Right.
and option two, where we survive but just don't simulate,
Right.
that both result in the same physical outcome for us. no simulations exist. So he collapsed those into a single probability bucket.
Ah, I see. So instead of a three-way split, it's just simulations don't exist versus simulations do exist.
Exactly. And since we have, zero evidence of other civilizations, let alone post-human ones, that no simulation bucket gets a lot heavier in his equation, his conclusion was that the probability is roughly 50-50.
So we went from almost certainly a sim all the way down to a coin flip.
A coin flip that's maybe slightly tilting toward base reality. But still, think about that. Neil deGrasse Tyson has said he can't find a strong argument against it. When you have top astrophysicists saying the odds are effectively a coin toss, that's significant.
Well, we have the logic, we have the probability, but that's all philosophy and math on paper. Let's move to the physical world. I mean, if we are in a box, shouldn't we be able to see the walls? Does the universe look like a computer program?
This is where we get into the hard physics. If you look closely enough at reality, does it look smooth and continuous? Or does it look, well, pixelated?
And you're talking about the Planck length here, I'm guessing.
I am. In our digital world, an image looks smooth from a distance, but if you zoom in far enough, you see the grid, you see the pixels.
Right.
In physics, we have this hard limit on how small things can get. The Planck length is about 1.6 times 10 to the power of negative 35 meters. It's unimaginably small.
It's the resolution limit of the universe.
That's the argument. If space were truly continuous, like a fluid, you should be able to just keep dividing it forever and ever. The fact that there seems to be a bottom, a smallest possible unit, looks a lot like a grid, a computational lattice.
But wait, I remember reading about an experiment that tried to find this, the Fermilab holometer. They didn't just theorize, they built a machine to look for this jitter.
This is a crucial piece of nuance that often gets left out of the hype, yeah. The holometer used these massive lasers to measure what they called holographic noise, trying to detect if spacetime was digitizing or vibrating at that tiny scale.
So if we were in a low-res sim, the lasers should have picked up some fuzziness.
A specific kind of fuzziness, yes. And did they find the pixel?
I'm guessing no.
They did not. Spacetime appeared smooth, at least down to the precision they could measure.
Yeah.
So that pixelated universe hypothesis took a pretty big hit there. We haven't found the jagged edges of the code yet.
Okay, so the graphics are better than we thought, but what about processing speed? We have a cosmic speed limit, the speed of light. To a believer, that just screams bandwidth cap.
It is a very suspicious constant, isn't it? Why is there a maximum speed for causality, for information? In a computer simulation, you can't have information moving instantly across the entire map. You need a processing limit to keep the whole system stable.
Otherwise, you crash the server.
You prevent infinite processing loops.
Yeah.
It's remarkably similar to how a game engine handles things like draw distance and data transfer. Neil deGrasse Tyson has that funny line about it.
Oh, yeah.
He suggested that maybe we can't travel faster than light because the system just hasn't rendered the distant galaxies for us yet.
We're stuck in the starting zone because the devs haven't finished the expansion pack?
Pretty much.
But speaking of rendering, we have to talk about the observer effect. The double slit experiment, this is the one that just always breaks people's brains.
It is the classic quantum puzzle. So when we fire particles, like electrons, through two slits, they behave like waves. They create an interference pattern on the other side. They're sort of everywhere at once.
Okay.
And here's the weird part. If we put a detector there to watch which slit they go through, they stop behaving like waves, and they act like solid, distinct particles.
So the moment we look, the game engine decides where the particle is. Before we looked, it was just probability.
Believers call this rendering on demand. The argument is that reality is an optimization engine. It doesn't waste memory or resources calculating the definite position of every single particle in the universe all the time.
It only renders the definite state when a player, an observer, actually looks at it.
Just like a video game doesn't bother rendering the room behind you until you turn around.
It's a striking parallel.
It really is. Now, physicists will tell you this is fully explained by wave function collapse and doesn't require a simulation. But it's undeniable that the universe acts exactly like a system that was designed to save memory.
If this is resonating, hit that subscribe button so you don't miss the next deep dive. We are about to get into how AI is changing this whole conversation, and frankly, this is where the sci-fi starts looking like next Tuesday.
We are definitely moving from what if to look at what we are building right now.
Okay, but before we jump to AI, we need to bridge that gap with this concept of information, because we usually think of the universe as being made of stuff. you know, atoms, quarks, physical matter.
Right.
But the physicist John Wheeler had this idea of it from bit.
Wheeler was a giant in physics, and it from bit suggests that at the very, very bottom of reality, there isn't matter, there is just information. Yes, no answers, binary code. Every particle, every force is ultimately just a bit of data.
And this isn't just like poetry, this ties into black holes, right? The black hole information paradox.
This is vital. For a long, long time, we thought black holes just destroyed everything, deleted it from the universe. But modern thermodynamics and quantum theory suggest that information cannot be destroyed, ever. Even if you throw a book into a black hole, the information about the arrangement of its atoms is preserved on the surface, on the event horizon.
So the universe acts like a hard drive. It never truly deletes data.
Which supports this idea that the fundamental substance of our reality is data, not rock or gas. Max Tegmark takes this even further with his mathematical universe hypothesis. He argues that math isn't just a language we use to describe the world.
He's saying the world is a mathematical structure.
Exactly. And since computer code is just functional math, if reality is math, well, reality could be code.
But let's bring this down to our level. We don't need a black hole to see this. We just need to look at what's happening in Silicon Valley.
The post-human capabilities that Bostrom talked about. We are seeing the absolute infancy of them today.
I really want to talk about that Stanford Google study from 2023, the generative agents one. This wasn't just ChatGPT writing a poem. They built a Sims-like town called Smallville and populated it with 25 AI agents.
This study was a watershed moment. They gave these agents basic identities. You know, you are John, you are a pharmacist, and then just let them run. No scripts for their day.
And the detail here is just wild. One agent, Isabella, was given a tiny suggestion that she wanted to host a Valentine's Day party. That was it.
And she didn't just do it. She went and found her friend Maria to invite her. But here is the kicker. Maria checked her own internal calendar, realized she was free, accepted, and then she went and told another agent, Klaus, about the party.
Wow. And it just cascaded from there?
It cascaded, they decorated, they formed opinions about each other. Klaus actually asked Maria to the party as a date.
No way. Nobody programmed Klaus to have a crush on Maria.
Not at all. That was emergent behavior.
That's the key, isn't it?
That is the whole crux. We witness emergent social complexity from a relatively simple setup. The agents remember their past interactions and plan future ones.
So if we, with our 2023 technology, which is basically stone, knives, and bearskins compared to a civilization a million years ahead of us, if we can create agents that plan parties and gossip,
then simulating a universe isn't magic anymore. It's just a matter of scaling up. If we can do this primitive version now, it makes Bostrom's premise that a future civilization could simulate us feel, well, almost inevitable.
It stops being a philosophy question and it starts being an engineering timeline. But let's pivot back to the listener experience. We started with that feeling of the glitch, the buffering.
The psychological side of the theory, yeah.
We have to talk about the Mandela effect. I know everyone listening knows the Berenstain Bears example. Is it Stein or Stain? But simulation theorists don't just see that as bad memory. They see it as a patch update.
Right. The argument isn't just, oh, people forget things. It's that huge groups of people share the exact same false memory. To a believer, that looks like a file got corrupted or overwritten in the source code.
And our memories are just holding on to the old cached versions.
Or déjà vu. That feeling is so visceral. To a believer, it's a playback error. The system accidentally loaded the same moment twice.
That's a great story.
It's a romantic sci-fi explanation. But as the skeptical voice here, I do have to defend the neuroscience. We actually have a pretty good idea of what's happening during déjà vu, and it's a hardware glitch. But the hardware is your brain, not the universe.
Okay, so walk us through the brain's version of the glitch.
It's basically a mismatch in timing. You have the temporal lobe, which processes sensory input and assigns a feeling of familiarity, and then you have the frontal regions that handle memory verification.
Okay.
Sometimes the familiarity circuit fires a microsecond before the memory check is finished.
So your brain stamps the moment as known before it actually processes what it is.
Exactly. It feels like a memory because your brain labeled it as one by mistake. And as for the Mandela effect, memory is reconstructive. We don't record video files. We store the gist of things.
We're compressing the JPEG and losing the details.
Perfect analogy. We remember the vibe, not the pixels. We know the name Berenstain sounds German. Stein is a common German ending. Stain is not. So thousands of brains independently autocorrect the memory to the more common pattern.
So these feelings, as real and strange as they are probably just bugs in our own biology.
It's much more likely they're bugs in our biology, not evidence of a simulation update.
Okay, you've been the voice of reason, but let's really let the skeptics have the floor for a minute. We built a pretty strong case, but why isn't this taught in physics class? What are the hard stops?
There are massive constraints. The first one is energy. It's called Landauer's principle.
This is the heat problem, right?
Yes. In thermodynamics, processing information, specifically erasing bits to overwrite them, creates heat. To simulate every single neuron in a human brain, let alone every atom in the universe, the energy cost is just astronomical.
Your laptop gets hot when you play a high-end game. A computer simulating a universe would basically turn into a star.
It would likely melt itself before it finished the first nanosecond, unless they're using physics we can't even comprehend. And then there's the sign problem in quantum mechanics.
This is the complexity issue.
Right. Imagine a pool table. Calculating the trajectory of two balls hitting each other is easy. 3 is harder. But if you have 1 billion balls all hitting each other simultaneously, the math doesn't just get linear. It explodes exponentially.
The calculator breaks.
The calculator breaks. Simulating quantum systems on classical computers just hits a wall where the complexity becomes unmanageable. It might just be that the universe is too complex to be simulated by anything smaller than the universe itself.
And finally, I guess the biggest critique of all, is this even science?
This is the falsifiability problem. For a theory to be truly scientific, there has to be a way to prove it wrong. But with simulation theory, if I find evidence that contradicts the simulation, a believer can just say,
well, the programmers program that evidence to fool you.
Exactly. It's the ultimate get-out-of-jail-free card.
Which moves it out of the realm of science and into
the realm of faith. It's modern metaphysics, not physics, if you can't test it.
And we can't ignore Occam's razor. The simplest explanation is usually the right one.
And base reality explains our existence perfectly fine. We are here because the universe evolved. Adding an invisible supercomputer and a mysterious programmer adds all these extra layers of complexity that we just don't need to explain why apples fall from trees.
So let's bring it all home. What does this all mean? We have probability saying maybe, physics saying it looks like a grid, AI saying we're almost there, and neuroscience saying it's all in your head.
If we synthesize all this, I think the simulation theory is useful even if it's completely false. It relies on a convergence of our best understanding of math, computing, and physics. It serves as a mirror, in a way.
A mirror to check our own reflection.
Exactly. Whether we're in a simulation or not, just asking the question forces us to understand our limits. It pushes us to define what consciousness is. It pushes us to test the very limits of computing.
Like, comment, and subscribe to hear more My Mind Mashups deep dives. Because whether you are a biological entity born of stardust or a complex algorithm running on a server in the year 4000, we appreciate you listening.
And here's a final provocative thought for you to chew on. Going back to that feeling of buffering.
The stutter.
If the universe is a simulation and we're starting to notice glitches, does that mean this system is failing? Or are we just evolving? Maybe waking up isn't spiritual. Maybe it's just noticing the resolution of the screen for the first time.
Are we the characters finally realizing we're in a movie? That is definitely going to keep me up tonight. Find My Mind Mashups everywhere you listen. Amazon Music, Audible, Facebook, Pocket Casts, Spotify, TikTok, and YouTube.
We really want to hear your take on this. Are you team-based reality or team simulation?
Drop your thoughts in the comments. Your perspective could shape our next deep dive. Thanks for listening, and we'll see you in the next simulation or episode. Bye.